proof by contradiction, we need to assume the opposite of what we're trying to prove and then get something that we just know is false. So the starting point is to assume that there is a greatest multiple of 5. Now, mathematically, we can write this down as capital N, for example, equals 5n, or some other symbol of your choice, but it's important to write it down mathematically. Now, let's say I've got 60 was my largest multiple of 5. Well, actually, 65 is bigger, and that's the process we're going through here, just algebraically. So I'm going to consider instead, um, maybe I'll call it capital M. You don't need to, I didn't actually give it a name when I did it myself originally, but capital N, M is going to be 5n plus 5, or 10 or 15, but I'm just going with the next largest one. Now, 5n plus 5 is greater than 5n for sure. So m is greater than n. And 5n plus 5 is equal, we can factorize out the 5 to get n plus 1. So m is a multiple of 5. But that's the problem, isn't it? Because we said that capital N is the largest multiple of 5, and then we've just shown that, first of all, m is bigger, and it's a multiple of 5. So this is a contradiction. And therefore, that's abbreviation for therefore, there is no greatest multiple of 5. Very important to write a little conclusion. All right, amazing method this. You might say, this is like, of course, there's no greatest multiple of 5. We can just keep adding 5. But we have used contradiction to show it. And in some cases, when it's not obvious, such as showing there's an infinite number of primes and so on, contradiction really comes into its own. But yeah, this is a nice example of it here too.